Back to my YouTube channel. Was still under Mechanotechnics N6. Our given example 6 reads as follow. A belt drive consists of 2 V-belts. Check the number of V-belts. N is 2, not 1, 2. And the allowable belt stress per belt, as you can see, is 7.9 megapascal per belt. The density of the belt is this, and the belt cross-sectional area of given in millimeter cubed, and coefficient of friction between the belt and pulley of given, which is 0.28, and the driving pulley has a diameter of this 875 millimeter, and the speed is 800 watt and 25 rests per minute. Then we have given the angle of contact on the driven pulley is this. Take a note. This is in degrees. This is in minutes. We've given 160 degrees, and there they have given also minutes there. And then the angle of rep must be what? Must be in rads. Must be in radians. So we're supposed to convert. We'll see what we do there. And the groove angle of the pulley is this. The groove angle of the pulley. Groove is the one for the V. Groove. So we'll talk about that because it's a V belt. Groove angle. Says here calculate the output power transmitted by the river. Oh, sorry, why I'm saying by the driver. I'm saying river. No, sorry about that. By the driver, if the efficiency of the drive is this, yeah, transmitted by the drive. If the efficiency of the drive is 65%, then so in on B, we're supposed to do that. Okay, let's start by A. We have given all of these things. So A, we've given A, but will be nice for us if we can do some that. Yeah, it will be a good idea if we can grab some data stuff there. So yeah, let me just let's check the data given. We're given, what are we given there? 2 V belts, number of belts, which is 2 V belts, and the allowable belt stress is that allowable belt stress in megapascal, given that in megapascal. Tension per belt, we've given tension per belt, ft per belt, which is what was that, 7.9 per belt. Okay, per belt. That is in that means this is the stress. It's in megapascal. It's fine. Then the density of given 1.3. Density 1.3 times 10 to the power of 3. Like this, we know. Coefficient of friction in the driving pulley is 875. Okay, coefficient of friction, right, and the driving pulley, which is the diameter, it's 8. It's in millimeter. Oh, this is incorrect. D will be equals to 875 millimeter. Then we've given, and the speed of the pulley there 825, that is the speed rest per min. So far, and we have given the driven pulley the angle of contact, which is 19. There is degrees, this is in minutes. We have minutes, degrees. So the groove angle there, this is 46. This is what we are given, but I know we're supposed to use the semi groove, not the groove. We're supposed to divide this by 2. This will be what is by is B. Yes, is almost is indicated by B. Will be that 46 divided by 2, 23 degrees. Yes, is measured in degrees. This so okay. Nevertheless, let's calculate the output power transmitted by the drive if the efficiency is that. So I've discussed about if we've given the efficiency, the output power will be output power over input power multiplied by 100%. Finish and clear. That is what so far I know, isn't it? This is what I know. When we are calculating the output power, if we are given the what is the Mr. efficiency there, right? So whereby the output power will simply equals to multiply, there would be P input multiplied by the efficiency, but this input power is given by T1 minus T2 multiplied by V, then include this efficiency. So is this we're supposed to have, guys? And this is our output power that they want. We're supposed to have T1, T2, velocity, then here, and the efficiency is the one that we are given. So yeah, let's drill. Let's drill. Let us drill. Let us drill. Let us drill. If we're given the diameter, let us check. I will start by calculating speed, because speed, always start by calculating the speed. Why? Is because the speed will determine whether we'll use TC or not. Start by velocity. Do not make an example. Do not make mistake about that. Do not end by velocity. Remember, if velocity we found it to be greater than 10 meters per second, we're considering TC. So start by determining a velocity. Velocity is pi. We have a thickness there. We are not given thickness in this problem, so dn over 6 is like this. The diameter here we have 875 millimeter. We'll divide that by 1000, will be 0.875, and there we have, which is this 825 revs per minute. 825 revs per minute, we divide by 60. What is the velocity? Is 37.8 meters per second. So this value is huge. This velocity that we get is greater than 10 meters per second. So since it's larger than 10, we'll consider what? TC. So it's important to calculate velocity first, so that you'll know we're supposed to include TC, right? So we know that our TC is equal to mass v squared. So we are forced to calculate the mass. The mass is what? is width multiplied by thickness multiplied by length multiplied by density, whereby this is simply area, right? Or is simply, this is simply what, volume multiplied by density, whereby this inside is simply area. I've discussed about these guys, so yeah, let us substitute there. Our width we've been given there. Do we given width? No, there's something that we are not given. What are we given? Something missing here. Cross section area. I given a cross section area of 825 millimeters squared. Take note there. Given a cross section area. So this we are given already. So simply just say that this will be area multiplied by length multiplied by density, like this, because already we have the area. But take note, you have given millimeter squared. You must know your convection to convert that to, you must supposed to have area is measured in meter squared. You're supposed to convert this to this. So if you convert this is the same as millimeter multiplied by millimeter, right? So but what, when you multiply these two will be what? We still have millimeter, will be millimeter squared, whereby this is what we want. So what about this one? We know m is equal to times 10 to the power of 3, but you have two of them, will be 10 minus 3 multiplied by 10 minus 3 m squared. This laws of exponents, this is the same as 10 to the minus of what? Negative 10. This is the same as 10 to the minus 6. This is how we convert to if you go to meter squared, you multiply by this, by 10 to the power of negative 6. So our area we have there, which is 825. Remember, it's in millimeter squared, multiply this by negative 6, like that. Length, I said always it become 1, does not change. The length, when you're calculating the mass, consider it as 1. Then the density, it was this. So yeah, it's a matter of punching, and we'll find that our mass will be kg per meter, because we use that as a meter. I've discussed these guys already. So yeah, this is what we have. This is what we have. We have this, so we can calculate TC, because even the velocity we have TC, centrifugal force. The mass is the one that we simply got there, 1,073 multiplied by the velocity is 30 watts, 37,8. We square this. Prestige. Punch this TC. What will be TC? Would be what? 532,43 Newton. So this is what we have. This is what we have. Now we want to remember on our formula the aim. I've showed the aim is to find T1. We have T1 there. T2. Velocity already we have. If we can get T1 and T2, will be sorted. So how can we get T1 and T2? T1 according to what we've given there. Remember, we've given tension per belt. So there's this area we must know, tension per belt, which is the stress. Don't forget your formulas that say strength stress, which is the can be maximum stress multiplied by the area. You still remember this. This is simply just cannot remember this. This is just the stress, guys. This is allowable. The allowable stress of that. This is the stress. Stress we have given stress per what that. So if we have given stress, or even if you don't say minus, but is this simply stress multiplied by air? We know this from N form. Then stress, as if we've seen that the stress there that we have the stress of 7.9, right? But that stress was in megapascal, isn't it? So if we use the area directly, check. Okay, let me start by writing area here. Let me say like this. Area, if you use the area is like this, 25. Remember, it's given millimeter, like this, squared. But we say when you convert, this will be times 10 to the minus 6. If you convert, you must also convert. If you multiply, if you convert, you must also convert this to megapascal. However, if you don't want to convert, that means this and that you must multiply by this result. If you don't want to convert, but you must know what you are doing, you must be very careful. However, let me just do my thing. Note 7.9 was megapascal times 10 to the power of 6. Let me specify. It's because by the laws of exponents, remember these bases are the same, 10 and 10. 10 minus 6 plus that we add will be what? 0. Yeah, we'll cancel. And then anything raised to the power of 0, it's 1. So, so this is the same as 825 multiplied by 7.9. Remember, these two will give us 1. So, yeah. So, must careful how you do your thing. I'm just showing you. Then if you punch that 6,517,5 Newton. We have now, what about T2? We have no other choice. T1 over T2 would use this. There's no, we don't have choice here. This is wrong. It's T1 minus TC over T2 minus TC. And then you theta, pardon my, multiplied by cosecant beta. Remember, we're dealing with groove, but this secant is same as 1 over sine beta. So I can simply write this as u over sine beta like this. There we go. T1, we got it there. There is T1, 651. TC is the one that we've calculated, which was 1532,43. T2 we don't know. TC is 1532,43. Then E, coefficient of friction, it was 0, yeah, we're supposed to know some stuff. Do you remember this is over 0,3? But what is the angle of rep? The angle of contact. We've given this to be this. it's 169 comma the degrees there, be careful, for minutes. This obvious will divide by 2 will be 23. The angle of groove beat, we know that would be 23. Here is the problem, guys. Here is the problem, but it's not a problem, but might be a problem where it is not a problem, because I know people, they tend to forget mathematics. So your ratio, all I know, guys, is that 1 minute is equal to 60 degrees. If I'm not mistaken, 1 minute is equals to 60 degrees. Right. So here we have 169 degrees. Oh no, we have minutes, which is 34 minutes. This is the same as minutes, guys. That symbol means minutes. What about the degrees? Multiply, cross multiply there. X will be 60 multiplied by 34. And then this simply what, 60 multiplied by 34, which is 2040. Right. It is degrees, but we must convert this to be in radians again. So in radians, we know if I convert this degree to radians, will simply equals to what? In radians will be 204 divided by 57.3. I want this divided by 57.3 must be in radians. Then this is 35,602 rads. Now oh, this is incorrect. Oh, so why remember that is decimal. Yes. That is 0. This is same as 0.3134 minutes, like this. Damn, but then no problem. 60 multiplied by 0.34, like that. Right. Then we add this. Let me check. Then divide by. So this is what it is, guys. Or let me make this thing is, because we'll round off, find out now your answer become easy. Now you can simply use what we know, the old school. Simply use the old school method. Old school method is that degree to degree, convert degree to radians. The same as multiplying by pi and dividing by 1/8. This is the old school. This would be in radians. Old school, you use this formula here. You will put your degrees, right? They will use you'll put your degrees, then you convert your stuff there, right? So you know how to, and then Yeah, there we have 169. But now the problem, okay, 169 degrees, but now it has the 34 like this. Then if you multiply this by that, here's the problem. Here it's in minutes, but you must know that 1 minute is equal to 60 degrees is equals to 1 minute, right? So remember here, this column is the same as 0.34 degrees. So we know that using the proportion 160 degrees is equals to 1 minute. Here this will be simply 0.34 minutes. 1 degrees you multiply be 60 multiply by 0.34, whereby we have here x, which is what is it, degrees. So 60 multiplied by 0.34, right, we'll have 20.4, which is x. This is in degrees, but we add, remember that it was 1.34. We substitute this with that now, so we have to add. Now we add, will be plus, because now it's in degrees, or 24 comma, right, multiply by pi over 1/8. It's up to you. Use this, or as you have converted these degrees, you can simply divide this by 57.3 if you want. It's up to you. So guys, as you can see, this is how it goes. So I will just plug this. I don't want to have many decimals. I'll just plug this directly. Did that, we know this will be multiplied by 169 plus 20 that we had there, comma what was 20.4 degrees, multiplied by pi over 1/8. Then let me try and reduce this. So that I will have some space. Yeah, let me try and reduce there. Multiply by pi, right? But we are not, we remember it was just only this, but again multiply by, we have the sine angle, which is 23 degrees. So yes, this side will have approximately I will have approximately 8.338. Then yeah, okay, let me punch that on the top. If we subtract, we'll have 4985.07, right, all over T2 minus 153.2,43. This is 3, it's 8,338. Then cross multiplying, we'll have 4985,0. Should be 8,338T2 minus 1,4 like this. Then it's a matter of maths. T2 will be yes, it's manipulation. T2 7 Newton. Yeah, we have T2 now. Let's go and get, we have T2 now. We can calculate the power. We said output power, I've shown you guys, will be T1 minus T2 multiplied by velocity multiplied by efficient. I've shown you how to, I did show you how to derive this from the output power is equals to input power. Remember, this is simply the input power. T1, there we have the, okay, T1 must always be big, isn't it? The velocity was 37,8, the efficiency 0.65. Here is the efficiency, 65%. And this output power would be 16,6 times 10 to the power of 3 kilowatts. No watts, but this must be per belt. Why per belt? Remember, we have not used the number of grooves here. Remember, we have given 2 belts, as we have determined for 1 belt. We have not considered the other belts. We must multiply the power, everything, the tension by 2, but we have never calculated. So this must be per belt. So the overall now for 2 belts, or total power or total output, must be equals to this 216,6 times 10 to the power of 3. Let me just write this kilowatts actually, because this is the same as kilowatt, right? Multiplied by what? By 2. Remember, with 2 belts, this will be we've already calculated this. This is not, what did I do there? Let me punch. This is I've already uploaded the 2 on the calculator. I've made a mistake. Must be 1,8 kilowatts per belt. So the total output must be 1 kilowatts multiplied by 2, because we have 2 belts. Then this must be 215,6 kilowatts. Right, this is for 2 belts. For Amapandai 2, for 2 pence. for 2 belts. So now since we have for 2 belts, we have done with that. Let's check number B now. Is the total that transmitted by 2 belts, because you've given 2 belts. The output power transmitted, again they want to now be output power transmitted if 60% sleep occurs. Okay, 6% sleep occurs on that output. Okay, this typical question of the output, you must know output power if we have the sleeps, right? If you consider the sleep, let me just say this will be, okay, let me just say output power, output sleep, let me put sleep, or I can say p sleep, right? P sleep must be the total, the number of this one, the output power, the total output power that you've calculated on top minus 6% then sleep. So this, which was that is 215.6, remember it's in kilowatts, minus 6, remember 6%, same as divided by 100 is the same as 0.06, but you take this also, this number again will be 1, you do like this, you understand? If I can say 215.6 minus 0.06, 215.6, you understand? Let me show you this sleep. You take this, will be 66% is the same as 0.06, but this slippage is the same as total, the one that we have, the one. Let me just, to make this life easy, just do like this, do not put sleep there, but to understand, just say PT again. I don't know, yeah, any that will be calculated on the top, the power that will be calculated on the top, then that we know is still this one, right? So punch, then this will typically give you 202 comma, round it to first decimal digits, will be 7 kilowatts. Remember this was in kilowatts, we've used kilowatts there because this was in kilowatts. So yeah, then what about C? Calculate the efficiency. We want the efficiency now. We have given the one, but now we want the efficiency. Calculate the efficiency of the drive if the motor delivers that power and the sleep is neglected. Now see, the efficiency, all I know is output power over input power multiplied by 100. So we know that here output is the one that, remember, is for 2 belts. The first one that we've calculated for 2 belts is 215.6, isn't it, over P out is that over the one that you've given, the delivery one, when efficient delivers this, which is this is an input, that would be an input the motor cannot be, if you have a motor cannot be output. Motor delivers an input power. We must know that motor does not transmit the output power. No. So that will be input, obviously it's the motor times 100. This will be 58%. So yeah, this is what it is, guys. These are necessary steps supposed to take. So thank you guys for watching. Please do not forget to subscribe to my YouTube channel and nicely click that notification button so that it will notify whenever I post a new video.